To solve this with the quadratic formula, you first need to put it in standard form. So to put it in standard form, we have to equal it to 0. So we're going to minus the 5 over, and we're going to add the 3x over. Now then the 5 minuses from the 10, but the 3x has nothing to add to, so I'm just going to simply put 3x over here. Now when I do that, I now have everything over here, so I need to put it in standard form. So the x squared comes first, then the x, which is the 3x, and then 10 and negative 5 leaves you 5. So make sure you have it in standard form. Next, we have to use the quadratic formula. So let's plug all our values in. We either have our a, our b, and our c. So quadratic formula is x equals the opposite of b, so the opposite of 3, plus or minus the square root of b, which is 3, squared, minus 4a, c, a is 2, c is 5, all over 2 times a, which is 2. Remember, a, b, c. And then from there, you simply have to simplify everything. So this becomes a negative 3, plus or minus 3 squared is 9. Negative 4 times 2 times 5 looks like it's going to be negative 40. And 2 times 2 is 4. And from there, we have negative 3 equal negative 3 plus or minus the square root of 9 minus 40 is negative 31. So are we done? Does 31 break down? No, 31 does not break down, but it's imaginary. It does not break down, but it is imaginary, so we're not completely done. My final answer is negative 3 plus or minus. Negative inside of a square root brings an imaginary out, because the square root of negative 1, you pull the square root of negative 1 out of it, leaving you 31 and a 4. Now if this square root could be simplified, simplify it, but we cannot simplify 31. It's actually a prime number. So that is our final answer. It is an imaginary answer. So make sure you get it to standard form. Make sure you plug in your ABCs properly. Be careful when you're doing the math. For completing the square, it's a different method. I need to get, for completing the square, I need to make it so that I have the x squared, the x, and a blank. In order to do that, I'm going to have to minus this 2x this way, and minus this 1 this way. It's kind of 2 steps in one. That cancels, that cancels. What it looks like I have here is I have now x squared for this. This right here is 8x, because this and this leaves you 8x's, plus a blank, because remember I'm looking for a blank, equals, on this side I'm left with a negative 1 plus something. So again, instead of equaling it to 0, you equal it, you set it up so you have your x squared and your x with a blank and your number over here. And then you're going to add something for both those blanks. The way you find that is you half the b, so you're going to half the b and square it. So when you half b, which is 4, and you square that, you get 16. So I'm going to add 16 to both sides. Now you're going to factor this. When I factor that, I get 16 and 8. This on top, this on bottom. These numbers, if you do it right, will always be the same. So you have x plus 4, x plus 4. Negative 1 and 6 is 15. Sorry, negative 1 and 16 is 15. I said it wrong. Then, this right here is a squared. Hint the word completing the square. Hint the phrase. So x plus 4 squared, the same, equals 15. And so basically we did all this so that we can get to this point. Because from this point we can solve it. Because from this point where we have a square, completing the square, a square equals a number, I can now square root both sides. And I have x plus 4 equals plus or minus the square root of 15. And then the last step is simply to minus the 4 over. So x is equal to negative 4 plus or minus the square root of 15. Now, can 15 break down? No. It does not have any perfect square roots that come out of it, so that is actually my answer. That is not negative, it's a real number, so we don't have to worry about imaginaries. There's my answer using completing the square.